Welcome to a sim code. Hi there. Thanks for watching. Be sure to like and subscribe for more great content. Heap Sort is a comparison-based sorting algorithm that utilizes a binary heap data structure to efficiently sort elements. The core idea is to first build a max heap from the unsorted array, where the largest element is at the root. Once the heap is built, the algorithm repeatedly extracts the largest element, which is at the root, swaps it with the last element of the heap, reduces the heap size, and reheapifies the heap to maintain the max heap property. This process continues until the heap is reduced to a single element, resulting in a sorted array. Heap sort has a time complexity of O n log n and does not require additional space, making it efficient for large datasets. It works in place, which is one of its advantages over other algorithms like merge sort, though its stability is not guaranteed. Function to swap two elements. This is a helper function used throughout the algorithm. Swaps two elements. This is crucial in heap sort because elements need to be exchanged frequently as the heap structure changes during sorting. Store the value of A in a temporary variable. Assign the value of B to A. Place the original value of A into B. After this, the two variables have been swapped. Function to heapify a subtree rooted at index I. N is the size of the heap. It changes during sorting. This function ensures that the heap property is maintained by checking if the parent node is greater than its children and making the necessary swaps. Start by assuming the root, I, is the largest. Left child index based on heap property. Right child index based on heap property. Check if left child exists and is greater than the current largest element. If left child is larger, update largest. Check if right child exists and is greater than the current largest element. If right child is larger, update largest. If largest is not root, it means the largest value is not at I, so we need to swap the root with the largest child. Swap the root with the largest child. Recursively heapify the affected subtree because swapping may have violated the heap property. Now, the subtree rooted at I is a max heap again, with the largest element at the root. Function to build a max heap from the input array. This process starts from the last non-leaf node and moves upwards. This function constructs a max heap from an unsorted array. A heap is a complete binary tree, and we can build it by heapifying all non-leaf nodes starting from the last non-leaf node. We start with the last non-leaf node and heapify each node going upwards. Why start at? Because any nodes after this are leaf nodes and already satisfy heap properties. This results in a max heap where the largest element is at the root. The heap is now ready for sorting. Main function to implement heap sort. This is the core of the heap sort algorithm. It first builds a max heap and then repeatedly extracts the maximum element, which is at the root, and places it at the end of the array, while maintaining the heap structure. First, we build a max heap from the input array. Now we start extracting elements from the heap one by one. The largest element is at the root, and we swap it with the last element. Then we reduce the heap size by 1 and heapify the root to maintain the max heap property. Swap the root, largest element, with the last element. Now the root is no longer part of the heap, so we need to heapify the remaining part of the array. Heapify the reduced heap to ensure it stays a max heap. At this point, the array is sorted in ascending order. All elements have been heapified back into place after each swap. Utility function to print an array. This helper function simply prints the elements of the array. Print each element of the array. Move to the next line after printing the array. Main driver function. This is the entry point of the program where we define the array, call the heap sort function, and print the results. Define an unsorted array. Calculate the size of the array. Print the original array before sorting. Call heap sort function to sort the array. Print the sorted array. Now run our code. That's a wrap for today. Hit like and don't forget to subscribe for more.